Professor Tomáš Zelinka, who is a professor of informatics at the Czech Technical University in Prague. He lectures basic and advanced lectures in the areas of communication sciences, specific telecommunications solutions for intelligent transport systems, telecommunications services management, and so on. He has published over 120 scientific papers, monographs, books, and university textbooks in physics, informatics, ITS, transport, telematics, and telecommunications. And it is our great pleasure to welcome you as you talk about multidisciplinary projects and their impact on society. That was a good one.
Yes. Good afternoon to all of you. Yes, I'm slightly hesitating if the tuning of my presentation is correct, because after a brilliant presentation of theoretical issues, I'm coming with very practical view on what does it mean multidisciplinary in one of the area of our life, and that's a transportation. What is a positive news, a good news, is that transportation is touching each of you. Every of you, from time to time, have to sit car and drive. And I'm speaking from the opposite side of that. That means how to support the transportation system to make you happy. And that's a very difficult issue because many of us are very unhappy with that, how the system is behaving and not saving our time. So, I will shortly speak about these acronyms which were understood as a multidisciplinary. Yes, they are. CITS means, well, I will come to it later. I will discuss it. VANET, another very, very strange word for you. Then I will show a little bit on an example of Václav Havel Prague Airport case. And then I will discuss a little bit issue of requirements and available solutions.
They actually recognize the airport.
Good for you. Before I start, I would like to remember some of the stories I was touched personally too. These stories are not from the newspapers. These stories are not from the journals. These stories I live or I lived or I have to live. First one is an announcement of a very charismatic person, John Chambers, CEO of Cisco, which changed the world of data communication definitely. Nobody doubt about it. About his vision how to change the world of voice communication. I was present in the time and he said, in 3 years, voice services will be converted from TDM, from classical voice, to voice over IP. After him was discussing it John Kozel, and he said, well, John is good, I know, but maybe as a mission, I wouldn't say 3, but 6 years. He was sacked after that. He was not welcomed by his CEO, and he lost his job because of this presentation. And remember, if I'm not correct, today is 2014. That means 18 years later, nothing happened. You still have a voice as it was. You have some tools like Skype or whatever, but it's a niche market. It's nothing important. And still there exists something which John Chambers, who changed the world in the data communication, was not able to change. So, and one of the reasons I can see, because in that time I was in business, and we did a voice over IP interconnection of network to network. That was a very specific business, namely for unregulated or not sufficiently regulated countries. We did a very good job together with Israeli companies and Cisco and many others. We were very successful, but our company, Global One company, which was quite a strong company, was acquired by Telco. And Telco, 3 weeks after acquiring and finalizing acquisition, they stopped it. And I jumped to Paris to the CEO of the company saying, why? He said, there is no rationale behind it. It's just a decision, political decision. Forget about it. That's it. So if we want to show, to understand how does it work, it's a question. What is behind it? Where is the rationale behind it? And very frequently, we can't identify it because it's a complex process, and somewhere something influences something. We know that money are important. We know they are not important, but they are on the first position. And sometimes it's policy, sometimes personal interest, but generally it's a complex issue. And this is what I will go through some areas, and I will try to explain how it is. The same story is about European Union decision directives, etc., etc. They decided about EATS, they call it, European Electronic Toll Collection System, which was already to be on board. Nothing happened. There was a decision about, in Europe, starting 2013, I think, that every car will be equipped with a unit which will enable communication car to car and car to infrastructure. Nothing happened. Why? Even it was more than the words of John Chambers. It was a decision. It was law. Nothing happened, etc., etc. And 3 years ago, I was here in Horten in fall time on an amazing show and conference of ITS. 17,000 people, Najib, 17,000 people paying, registered. Amazing. And what has happened 2 years later? Nothing. So it's is the world where we are, is the world where we want to find ourselves, and where we want to find a way how to predict our behavior, where to go, how to go to...
Getting better.
That was a message for you, you know. So, coming back to this acronym, CITS, Cooperative Intelligent Transport System. Be aware whenever somebody speaks about himself as an intelligent, that has a problem. So, intelligent transport system is a real area of a business, but intelligent is very limited. And we see it when we are sitting in a car, in a line, waiting, nothing happens. There is the intelligence. But coming back to the car, car is a specific element of the society, specific element of the family. I remember in 60s, I was in London, in England, and a lot of British gentlemen should call car as a she. They had a really personal relation to the car. It's over, it's not here, but still car remains as a very important member of the budget of the family. CapEx, OpEx, that's everything which costs a lot of money, family, to be transportable, to be in. And if we spend such money, we expect that the infrastructure will be open for us, and the infrastructure will give us a space to explore that money we spend continuously and in one CapEx occasion per 2, 3, 4 years, it depends on how rich we are and how much of money we want to spend. The problem is that there is no one car. There are many cars on the roads, and the result is that. And what we as a society can do with it, we can either extensively invest money, if we have any, or we can start process to do the transportation system more efficient. And that's what's behind ITS. Even intelligent is with the comments I already said. So how we do it? We have authorities, we have systems. Systems are shown by computers on the right-hand side, and these systems are communicating with the units, that means with vehicles, in 3 different ways: as a localization of each of the subject or groups of the subject, as a identification of the status, That means sometimes we do it with, nowadays with tracks, how the driver is exhausted, trying to measure the potential of accident, etc., etc. And the third is identification of the owner of the car or driver of the car. It's important because a lot of these services are paid. And if we want to collect money, we need to have an appropriate association via a wireless system, which is always in doubt if it is legal, illegal, etc., etc. But this must be done. And to be done it correctly, ITS use performance indicators as a probabilistic functions describing how does it work, how if we fit or we do not fit to the expectations. How to find a position, GPS. GPS is something which is living with us for 20 years, not improving the parameters much. Expectation were, for instance, with Chinese, Russians, Europe was to come with Galileo 5, 6, 7 years ago. Nothing happened. And America has a GPS, which is a, well, comme-ci, comme-ça system done 20 years ago. And nothing happened because there is not expectation of business. Businesses, they already have the second generation, but only 1/3 or 1/4 of the satellites on the orbit are of this generation, so the services are not supported because we should need a guaranteed services. And these services are not guaranteed what we have and not available. They are guaranteed, but for Pentagon, for Navy. Navy has an alternative which is good enough, but this is not available for ordinary people like we are. The second way how to measure the position are the countries you well know in the US, and we have some of this mutation coming from Austria, for instance, from Kapsch company in Europe as well, still growing, and this is combined with communication, car to infrastructure and car to car, and that's the beginning of cooperative ITS system, because the car can communicate one to each other and is starting to build a cooperative system, which is important for the future behaving of the system, because they can understand who is who and what are the parameters of each of the partners in the networking. Okay, and communication and positioning is influencing the parameters of the service. So this typical multidisciplinary area where very different areas are connected and must very closely cooperate together. I could speak hours and hours about how we calculate the influence of each parameter on the result of the system. This is ready, this is available, and this is the most multidisciplinary part of it. The communication can be either that what you mentioned, this is a European funny alternatives produced somewhere in Portugal or somewhere in eastern, in a western part of Europe. This is definitely one of the most expensive way how to do it. And these are the alternatives on the way where car can communicate either car to car, car to infrastructure on a local way, as well as a car to infrastructure on a way of public services, which is a little bit different scale of communication. Yes. So these are the tools available. And what are the expectations? The expectation in a time are in minutes for tools supporting traffic efficiency management. That means I don't need online. Bill Gates is a funny guy. So that's the first, the lowest requirement. Then the post-crash services, like in Europe, we speak a lot about the so-called e-call, emergency call. In a moment when a car gets in troubles, in an accident, there is a unit which collects the information, was that of the car, what is available, like number of airbags, etc., etc., and it sends the information to the central station where they decide who will and how will act in case of such an accident. So they can select the position, the nearest by emergency service for healthy. They can decide if there was too many airbags that they will be in a bad condition, so they need a better support, medical support, etc., etc. So they have enough of information to do it, and they act. So this is the European project, and this is one of those projects I mentioned as a nightmare. It's not done yet, even it was to be expected, already implemented. We have, for instance, in the Czech Republic, one of these systems as a pilot, still as a pilot. So, and only a few people have it.
Do you have information if there is an American project doing something like that?
I don't know. It's too far in distance to cross the Atlantic Ocean. The fastest requirements are the ones which are closest to my heart, which are something which is really helping, and that's a pre-crash support or a crash information system. That means you are driving on a highway in Germany, 200 kilometers per hour, and you get in time information, you get immediate information that 200 cars in front of you had a crash. And this information is given to you, and your car can act in a way that you will not be a member of this crash, because you are informed in advance enough to act. But the issue is that the requirements on such an information system is that it should be faster than 100 milliseconds. If it is so, it's perfect. So, generally speaking, one of the top issues is security. We start to communicate car to car. That means there is a communication network, technological network to technological network, and above that, which is for a technological network to global network. And we know what does it mean hacker. We know what does it mean ill will. And this must be treated well enough not to get us in troubles. One of the tools is authorization, authentication. These are the tools which have to be included in the processes, but these processes are still time demanding. And if we are in America on the big crossing, there is no problem to have 500 cars available in the area of half a kilometer diameter. And these cars should communicate one each other 10 times per second. So there should be 5,000 communication per second in each car. There are not such a technology available nowadays on this scale of CPUs or generally these elements to fulfill this requirement. So, but we know how to do it because this is an area where a lot of effort was done, combination, hybrid solution, a combination of symmetric and asymmetric encryption, etc., etc. This is something that I don't have any question mark. Yeah, I have to hurry. Yeah. VANET. What is it, VANET? VANET is a Vehicle Ad Hoc Network. Vehicle Ad Hoc Network is a specific type, a special type of ad hoc network, and even a specific type of mobile ad hoc network. Why specific? Specific because of many reasons. One of them is the speed of a mutual movement of different elements. As I said, in Germany, there is no problem to generate the speed of 400 kilometers between, but they don't have a limit. So they can drive as much as they like. So two cars, two BWM cars are driving against each other on the highway, 400 kilometer speed, mutual speed between them. And they should communicate. And that's the issue which is one of the core issues of the how to construct such a VANET networks. In a city, it's quite simple. In a city, it's not fast, and you can build an infrastructure, and such systems are easy to install on the roads. It's quite difficult, but we know about clusters, approaches, and using clusters, structures, where you decide you have information. Each car is equipped with GPS, so everybody knows the position of the others, and they can build the clusters of those who are in right relation of the speed of the system, and such a system then can closely and effectively
A
cooperate.
very short question. Is there any technical reason why ad hoc is written with CK and not just with C?
No, maybe my bad knowledge of English.
No, it's not, because in Google you find that both expression, ad hoc with CK and ad hoc. Look at it. Yeah, I saw it.
One is an error, and one should be an error. But
Yeah, but I saw it all the way.
Okay,
Okay.
so I will speak shortly about the specific situation as a model situation on airport territory. How much I have? 10 minutes? Or?
Yes, you've got 10 minutes.
10. So this is an example we were very lucky to get in, and that was an airport where we've got in a project. And why we were lucky? Lucky we were because of a very strictly defined area and very strictly operated area. If we decide to have a car with such a functionality and is accepted by authority of airport, everybody who is on the airport territory must be equipped with such equipment. So we were lucky to get it, and we developed a system which is able to inform every driver about position of all drivers surrounding him. So he has on the screen, on his screen, information not only about his position, but he has information about position of the others, about position of aircrafts rolling somewhere around, plus information about zones, where he may go, where he may not go, etc., etc. And this system was installed and is operational, installed not by university, of course, installed by the company later on. And this is an example of cooperative ITS system. Even it was developed in time where cooperative was not sexy as it is now. Now everybody who wants to be in, he must use a cooperative ITS system. But it's more sexy than the real content of it. We did it before and it was working. So this system is able to manage position of the cars, and it helps to support the dispatcher to control the system. We use two types of positioning of the cars. One is a GPS, and the second one is a radar-based system. One has the information in cars, second one has the information in center, and they have to exchange the information. And this is the story about how to manage the communication to fit the requirement of performance of the airport. We did it in a way that finally we broadcasted position of all cars in a broadcasting regime, because in the other way we were not able to fulfill the quality of the service. So we are just now in implementation conditions. If we want to do such a system like we did in airport territory, we need to have the same condition about equipments in all cars. Some people from ITS say that it's enough to have a 20% of cars equipped. You know, it reminds me changing of the driving from the left-hand side in the United Kingdom, from left-hand side to right-hand side, when you start to do it only with lorries. Only lorry will drive on the left and the rest on the right. You know, that's not possible. So one of the critical requirements on such a system functionality is that all the units are equipped, every vehicle is equipped with such a tool. There is a lot of available solution with different car vendors. BMW does it, Ford does it, Volvo does it, but they don't want to cooperate. There is not identified strong enough spirit of global cooperation. and that's the problem. You maybe notice the information that there will be very soon automatically driven cars on the streets. Everybody speaks about it, but even if they are not able to agree on the one way of communication between the cars, where is the reality of such a proclamation? That's a typical issue for the future. What it will come with? Essentially improve efficiency of the transport, no doubt. Improve security of users, no doubt. Improve transportation service reliability and comfort. All these are impact on the society, very strong impact on the society. But who is the ruler again? R&D, economy, market players, authorities? Again, only question mark, no answer. So let's go back to the multidisciplinary stage, and this is telecommunication in ITS system. We speak about application of second and third generation of mobile telephony. Coverage is good, it's everywhere, but the latency is critical, it's above expectation. I don't know if you notice, we don't use most of you GSM, but GSM GPRS service, the first data packet service, has a latency of 700 to 800 milliseconds. So it's 5-6 times more, 7 times more than is expected. Third generation is a little bit better, but still above 200 milliseconds. We measure it, we didn't trust it, we measure it in the labs of one of the providers, so we know exactly how it is. Wi-Fi was our solution for airport, but it's abandoning and is replaced by LTE for some reason, which would be for another presentation. Wi-Fi, understood as a niche market, strange market, has awaked and came with a version P, which is able to tolerate up to 400 kilometers per hour. It's especially designed for vehicle-to-vehicle communication, and it's available, it's adopted by IEEE in the standard 1609, which supports the full regime of communication, and it's definitely the solution. The problem of that solution is that from each kilometer on a highway or on a road, you need to have a base station. Base station controls the traffic, controls the quality of that, and who will do it? Who will invest in it? Who will operate it? Another problem. So I will shortly end with the question marks only, because all of that what is nowadays a boundary to be implemented will be discussed. Mobility of fourth generation, that's what's coming, what's here already. LTE, you see everywhere, everybody is providing LTE, but LTE are from generation 8 to 12, so we are on the halfway to fourth generation. Fourth generation mobility is again acceptable, bit rates, it's above expectation. Latency, 10 milliseconds, perfect for us. Handover time, 27 milliseconds, perfect for us. So everything is good, everything looks very promisable. And above that, in release 12, which will not be 2014, but maybe 16 already, is delayed like everything. There is expectation to have a communication terminal to terminal. And you are on the position car to car, car to infrastructure. So everything is coming with this fourth generation, what we were dreaming about. The only issue is that operators are not ready to provide service of such a quality. Whenever I speak to operators, they say, we don't like such a business. Our core business are people which are not demanding much. They are generating volumes, they are generating money for us, and they don't demand to have a response time, they don't have a demand to have a guaranteed quality, etc., etc. So we have technology, but I have a great doubt about it if we are able to force operators to produce such a product which will be available and relevant to such a demand. Okay, so there is an alternative. This drawing was drawn in one of pubs of Paris 15 years ago by ISO people. A similar approach was done by IEEE as well. And the idea is you have the system, and the system can combine different technologies in the way of standard ISO model, and it gives ability to choose and to hand over from one technology, seamless handover from one technology to the other technology. So in case your operator is not ready for it with WiMAX, you can go to Wi-Fi solution, if not to 3G, etc., etc. This should automatically be done. It's ready system in a system. The problem is that the technology of ICs of these chips is not ready for such a strict, nice structure which were defined. A new chipset is completely needed, which is a lot of money invested in it. Question is, will be there will to do it? So at the end of the endings, in a conclusion, because I promised to be in time and I'm close to it, I would like just to say, yes, we have technology available. We have ideas available. Everything is ready. The question is, again, who is ruling the implementation, and will be the implementation possible due to multidisciplinary structure of the products? Will be this multidisciplinary dealing providers willing to provide appropriate service to improve the life of the people? It's real improvement of the life of the people. Question is there a will to support it? And this is the last question mark. I will stop just now.